Salam everyone and welcome to Electronics. My name is Fatima Graba Yusuf and I'm here to walk you through Chemistry 2021 past questions and answers for Jamb UTME. So the first question here is, which of the following is suitable for producing insoluble salts? We have A. Thermal decomposition, B. Neutralization, C. Double decomposition, and D. Oxidation. So actually the method that is suitable for producing insoluble salts is double decomposition. It is done through a precipitation method. So our answer here is C, double decomposition. Next is question 2, which asks, octane number is highest in petrol containing a high proportion of A. 2-methylpentane, B. Octane, C. 2,2,4 trimethylpentane, and D. 2,4-dimethylpentane. So octane number, which is also called anti-knock-rating, is actually a measure of the ability of a fuel to resist knocking when ignited in a mixture with air in the cylinder of an internal combustion engine. So you can see that it's like a measure of the quality of a hydrocarbon, which is petrol in this case. Now the best, or should I say the hydrocarbon with the highest rating number is 2,2,4 trimethylpentane, so it is our answer in this case, which is C. Next we have the third question, which asks, which of the following scientists discovered the neutron? We have A. J.J. Thomson, B. R.A. Millikan, C. Ernest Rutherford, and D. James Chadwick. So the answer to this question is James Chadwick, who discovered neutron in the year 1932. So our answer here is C. Question 4 asks, electrolysis is applied in the following processes except A. Extraction of aluminium, B. Extraction of iron, C. Purification of copper, and D. Electroplating. So sometimes when you are faced with multiple options and you're not sure which one is the correct answer, it's good to tick off some of those options to leave the ones that are more likely to be the answer. So here now it's common knowledge that electroplating is actually done using electrolysis, and there's also purification of copper when you have impurities with copper. So you are left with extraction of aluminum and extraction of iron. Likewise, if you have gone through your chemistry notes diligently, you'll know that extraction of aluminum is actually done using electrolysis, but not extraction of iron. So your answer here is B, extraction of iron. Then question 5. Here you were asked, how many orbitals are in the D subshell? So actually there are 4 subshells. We have the S, the P, the D, and the F subshells, and each of them has an odd number of orbitals. So S orbital has 1 subshell. The next is P orbital, which increases by 2. That is, it has 3 subshells, or it has 3 orbitals. The next is the D subshell, which contains 5 orbitals, and the last one is P subshell, which contains 7. So here we were asked about the D subshell, and our answer is 5, that is D. Then question 6. Here you were told, pig iron is brittle because it contains A. Undecomposed limestone, B. Calcium triosilicate 4, C. Unreacted hematite, and D. A high percentage of carbon as impurity. So actually, as the major disadvantages of pig iron in some applications is that it contains a high percentage of carbon as impurity. So our answer here is D. The next question says the earthly impurities in iron ore are removed in the blast furnace by the reaction. So we're given a range of reactions A, B, C, and D. Now it's very important for you to actually take note of some takeaways that are usually given in questions. For example, here you were specifically told earthly impurities. And what is earth? Earth contains things like sand, right? So that means you should be on the lookout for the option that contains the removal of a sandy component, which is C, because it contains the reaction of silica and calcium oxide to form calcium trioxosilicate. So your answer here is C. Next, you were told that when 100 cm³ of a saturated solution of KClO3 at 40 degrees Celsius is evaporated, 14 grams of salt is recovered. Then you were asked, what is the solubility of this compound at 40 degrees Celsius? And you're also given the atomic weight of the compound to be 122.5 gram per mole. So the formula for solubility is you have to calculate the number of moles of the solutes, and then you now divide it by the total volume, which is, in this case, you have 100 cm³. But then we need to do some conversions here. That is, we have to calculate the number of moles of this compound using this reactive mass, this 14 gram, and this molar mass. And then we also need to convert this 100 cm³ to dm³, because you can see all our options are in mole per dm³. So I'll go and do a quick solution here. You were given your volume to be 100 cm³. If you're going to convert it to dm³, it will give you 0.1 dm³. This is because 10 centimeters make 1 decimeter. Therefore, 1000 cm³ is supposed to give you 1 decimeter³. So here, since we have just 100, you can see 100 divided by 1000 to give you 0.1 dm³. Okay, you're also given the molar mass to be 122.5 gram per mole, while your reactant mass is 14 gram. So to calculate your number of moles, you have m, small letter m, divided by your capital letter M. Here we have 14 grams divided by 122.5 gram per mole. So when you divide this, it will give you 0.1143 moles. Now it's left for you to just use this value and divide it by this volume you converted to get your solubility. Your solubility will now be S is equal to 0.1143 mole divided by 0.1 dm³. So if you divide this, it will simply result in the movement of this decimal place from 1 to n, because you're dividing by 0.1, or you can say it's 10 over 100. So 10 over 100, when you're dividing by 10 over 100, your 10 will remain in the denominator while your 100 will jump up, and 1 0 will cancel the other. So it will result in increasing this with a multiple of 10. That is 1.143 mole per dm³. Now among your options, you have 1.14 mole per dm³, which is C, and that's your answer. Now next is the question 9, which asks for the oxidation number of iodine in the iodate ion, that's IO3 minus. So here too I'm going to do a quick calculation. So we have I, we have O for oxygen, we have 3, and we have minus, and we were asked to find the oxidation number of oxygen. Oxidation number of your iodine here. So basically the valency of oxygen is common knowledge. It's -2, right? So what you're going to do is we're going to balance this up to find the oxidation number of iodine. So we can represent it by X. So we will have X plus, Since we have 3 atoms of oxygen here, we'll have 3 into -2. Then it will be equal to -1, since this is not a neutral compound. Right. Equal to -1. So we find the value of x. Here we are left with x minus 6 is equal to -1. When you take this to the other side, it will give you x is equal to plus 6 minus 1. That is equal to plus 5. Now when you check your options, you find out that it is option B. That's plus 5. The next question is, what type of chemical bonding is involved in the formation of ammonium from a molecule of ammonia and a proton? It's supposed to be a question mark. So for you to better solve this or to find the answer of this question, you can just quickly sketch how the ammonium ion really looks. So let me just do a rough sketch. We have nitrogen with its 4 spaces around it, and you have, when it is now ammonia, it has 3 hydrogens connected. When it turns to ammonium, you add another hydrogen, but it is a proton now. So this will now give you ammonium. Now this technique is done in the process of dative bonding, which is also called coordinate covalent bonding. So that implies that your answer here is dative bonding, which is B. Then question 11 says, why is potassium fluoride added to the electrolyte in the extraction of sodium from fused sodium chloride? Now actually the melting point of sodium chloride is very high, which makes it quite difficult to extract sodium from it. Potassium fluoride is actually added to the electrolyte so that it will reduce the temperature. So as you can see, your options here are pure sodium. A, pure sodium chloride does not conduct electricity. B, sodium fluoride prevents the sodium produced from attacking the electrodes. C, potassium fluoride reduces the temperature at which sodium chloride fuses. And D, potassium fluoride increases conductivity. So from the short explanation I did, you can see that your answer is C. Potassium fluoride reduces the temperature at which sodium chloride fuses. Of course, it's not even A, because sodium chloride actually conducts electricity. Then the next question, question 12, it goes like this. Which of the following statements is not a postulate of the kinetic theory of gases? Actually, there are a number of statements in the kinetic theory of gases, among which are the intermolecular forces are actually negligible. Then the collision between the molecules is perfectly elastic. Also, the molecules are in a constant random motion. What is not contained in the kinetic theory of gases is that the molecules move with the same speed. Because obviously when they have different temperatures or they are energized in one way or the other, one molecule can move faster than the other. So your answer here is A. Then question 13. Here it's a question on radioactivity, and you were told that an atom with an atomic number 92 and a mass number 238 decays by alpha particle emission. Take note of this, alpha particle emission, to give an atom Y. So you were now asked to give the atomic number and the mass number of Y, that is the new atom that was formed. Here also I'll do a brief calculation. So we have our X with atomic number 92 and mass number 238, and we're told that it passes through alpha emission, and the alpha particle can also be represented by the helium atom, which has an atomic number 2 and a mass number 4. So this implies that this is actually broken down to Y with a particular mass number and a particular atomic number plus your helium with 4 and 2. So since you have to balance the number of your protons and your mass number, it simply means that to get your y, you just say 92 minus 2, that is 90, and 238 minus 4, that is 234. So this way, when you add this together, it will actually give you this, and when you add this together, it will give you this. So that means your answer here is the option that gives you 90 as your atomic number and 234 as your mass number, which is A. Then question 14 says, which of the following are chemical changes? You have I, cooking of food, II, digestion of food, you have III, freezing of water, and IV, heating of water. So obviously they believe that you have multiple answers to this question. So they asked you whether the answer is I and II, or I and III, and so on and so forth. So actually, when you take a look at these scenarios, freezing of water and heating of water are actually opposites, and they are reversible processes. So this implies that they are physical changes, not chemical changes. As for cooking and digestion of food, they involve the changing of the substance or the raw material or the food from one form to another, and it cannot be reversed. You can't eat something and then somehow it is reversed to its initial format. Likewise, cooking. So therefore your answer is A, which is I and II. Next is question 15, which says, which of the following equations does not illustrate correctly one of the reactions of carbon dioxide? So carbon dioxide gets involved in a number of reactions, and like I mentioned earlier, sometimes it's actually better to cancel out the wrong one out instead of thinking of which one is actually the correct one. So here too, you can take a look at these options, or you can try balancing them up, but my eye was actually caught by this option C here, where they said carbon dioxide plus hydrogen gives this, when in actuality, when you react hydrogen and carbon dioxide, it doesn't give you this. Instead, it gives you methane and water. So you can automatically know that this is your answer. Next is question 16, and now we are going to be involved in questions relating to the periodic table. We're told that use the table above to answer the question. Which of the letters indicate elements which exist as diatomic gases? So if you know your periodic table well, you know that the elements in group 1, which are the alkali metals, as well as the halogens, which are in group 7, usually exist in diatomic forms. That's why we have hydrogen and so on and so forth. So your answer here is A and F, that is B. The next question, which is also a question on the periodic table, asks which of the letters represents an alkaline earth metal. So alkaline earth metals are actually the elements in group 2. Group 1 elements are called alkali metals, while group 2 elements are called alkaline earth metals. So you can see that the only option we have is C, and it is the one right here in option C. Then moving on, we also have another question on periodic table, which says which of the following pairs of letters denotes elements containing the same number of electrons in their outermost shells. Now the feature used to characterize elements in the periodic table according to groups is actually based on their number of electrons in their outermost shells. So here you can see that the only elements, two elements that are contained in one group are either A and E or B and G. So here we don't even have A and E as one of our options, we only have B and G. So our answer here is D, which shows B and G. Then question 19, needs a bit of calculation. You were asked to calculate the quantity of electricity passed when 0.4 amperes flows for 1 hour 20 minutes through an electrolytic cell. To solve this, you need the formula for calculating the quantity of electricity, and I will use it to calculate this. So the formula is Q is equal to IT, where Q represents the quantity that you're looking for, I represents the electricity in amperes, the current, in amperes, while T represents the time in seconds. So here we were given our I as 0.4 amperes and our time as 1 hour 20 minutes. So we have to convert this to seconds. It's either you convert everything to minutes and then to seconds by saying we have 60 plus 20 minutes, that's 80, right? And when you convert it to seconds, it will be 80 times 60, giving us 4,800 seconds. So you use these values to calculate your Q. Q will now be equal to 0.4 times 4,800. So you can use one of these zeros, one of the tens here, to move this decimal place forward to give you 4 times 480, and this answer will be in coulombs. So when you multiply this, you get the answer as 1920. This is 1920 coulombs. So you now go back to your question and you see your answer is option A. Then question 20 says, which of the following will affect the rate of formation of sulfur, solid sulfur, in the reaction represented by the equation below? So we have this equation here, and you were asked what will affect the rate of formation of this sulfur. So there are a number of things that usually affect the rate of formation of a product, and one of them is removal of one of its accompanying products. So here you can check these options and you see where we have removal of water, which is the accompanying product of sulfur. So you can have that as your answer, because when you remove it, it will facilitate the formation of sulfur. Next is a question which says, when ammonium chloride in solid form was dissolved in water, the container was cooled to touch. Now what this means is that when this solid substance was dissolved in water, heat was absorbed from the container, which left it feeling cold. And this is the definition of what happens when a process is endothermic. That is, it absorbs heat from the surrounding. So your answer is C. Next is question 22, where you also need to do a bit of calculation. It says, what volume of hydrogen gas at STP will be produced when 48 grams of magnesium reacts completely with dilute hydrochloric acid? So this is saying that at standard temperature and pressure, when you react magnesium with hydrochloric acid, what volume of hydrogen gas will be liberated. To do this, it will be best for you to write out the equation to balance it out and then do your calculation, because this is based on stoichiometry. So to do that, you write out your equation. You have magnesium, right, reacting with hydrochloric acid to give magnesium chloride and hydrogen. But you need to do a bit of balancing. Magnesium chloride is written this way, and then you have hydrogen. So what you need to do is you need to balance your hydrogen and your chlorine, and you do that simply by adding 2 here. So you can see we have 1 magnesium, 2 hydrogen, and 2 chlorine. So you also need to know the atomic masses of these different elements. You have magnesium to be 24 gram per mole, we have hydrogen to be we have hydrogen to be 1 mole, gram per mole. We have chlorine to be 35.5 gram per mole. We'll need this in our calculation. Then you now do the proportionate calculation. So earlier in this equation, we have 24 gram per mole of magnesium, resulting in this hydrogen. So this hydrogen is an entity which contains 22.4, a volume of 22.4 dm3. You know hydrogen is not separable, right? So you can do your proportionate calculation by saying, okay, 24 gram of magnesium results in 22.4 dm3. Now it's because our options are actually in dm3, that's why we are using the dm3 instead of using this gram per mole to do the balancing. Then your question asks you for 48 gram of magnesium. So you now calculate is, you can maybe let it be B. So you cross multiply. You can say 24 times B will give 48 times 22.4. And to find your B, you have to divide both sides by 24 by 24. You don't have to worry about multiplying and then dividing. You can just simply simplify. Here you cancel out. Then 24 will go into 24 one time, and then into 48 twice. So you are left with 44.8 dm3. So now go back to your question and check out the correct option, which is C, 44.8 dm3. Then 23 says, which of the following types of hybridization is found in tetrahedral molecules? Tetrahedral implies four-sided, right? So here we have 1s and 3p, and that is what is going to give us 4 angles. It's our correct answer. That is C. This is based on organic chemistry. Then question 24 asks, which of the following reaction represents the laboratory preparation of hydrogen? Now, to prepare hydrogen in the lab, you usually use metal and react it with a dilute acid. So if you check here, which one of them contains a metal and a dilute acid? Here we only have copper and water, a metal and water. Here to sodium and water, here to carbon and water. But here we have zinc and hydrochloric acid, which is aqueous, that is dilute acid, right? So when you react zinc and hydrochloric acid, it will give you zinc chloride and hydrogen. So it's your correct answer, D. Then question 25 says, consider the reaction aluminium and hydrogen given this, and we asked what is the total number of electrons transferred. The next question is question 25, which says, consider the reaction between aluminium and hydrogen ions to give aluminium ions and stable hydrogen. So we asked what is the total number of electrons transferred from aluminium atoms to hydrogen ions. And this is a question based on redox reaction, that it involves both reduction and oxidation. That is, for one of the species there's a gain of electrons, while for the other there's loss of electrons. That's, electrons are transferred from one to the other. So here we only have 2 species. We have aluminium and hydrogen. We were asked what is the total number of electrons transferred from aluminium atoms to hydrogen ions. This is simply telling us that aluminium atoms were the ones that lost electrons, and the term used to define losing of electrons is oxidation, while the term used for gaining of electrons is reduction. So to find the total number of electrons that were actually transferred, it's either you do the balance for aluminium or you do the balance for hydrogen. So I'll do that in a quick illustration. So this is the equation, right? It's either we find out the number of electrons that were actually lost by aluminium, or the number of electrons that were gained by hydrogen. So let's start with aluminium. We have this as a neutral atom. That means it has no charge. 2 times 0 will still give you 0. So aluminium balance. We have 0 to give. Here we have a 3 plus charge. So 2 times 3 plus is 6, right? That's 6. While for hydrogen balance, initially there were positive ions here. 6 times plus 1 will give you 6, and then it turned to a neutral atom. That is 3 times 0, which will give you 0. So you can see aluminium lost 6 electrons, and those 6 electrons were actually transferred to hydrogen. So we will only ask for the number of electrons, and you can select B as your answer because it contains 6. Then the next question is, a chemical process in which there is a gain of electrons is known as, I already mentioned it earlier, gain of electrons is a characteristic feature of reduction, while the loss of electrons is oxidation. So here your answer is B, reduction. And the next question says, what is the chemical name for the compound CuCO3? Now to tackle this properly, you can see that all the options are actually copper compounds, and this is copper elements. Well, when you want to determine the chemical name for the compound, it is a good idea for you to split it into its component ions, because this is formed by, it's an ionic bond that forms this compound. So I'm going to write out this CuCO3. You can see that this was actually formed from copper and calcium trioxocarbonate, but then these are actually ions. Calcium trioxocarbonate has a charge of 2 minus. Now this implies that if this was actually formed using ionic bonding, then the charge on this copper must be equal and opposite to the charge on the other one. This is the cation and this is the anion. So here it implies that this charge is actually 2 plus. That is how when they are bonded together ionically, they result in a neutral compound. So this implies that in naming this compound, you will have copper 2 representing this, then carbonates. So check this out now and see which is your answer. That is B. Your answer is B. So we move on. Question 28 says, brass is an alloy of copper and you have A, zinc, B, iron, C, tin, and D, chromium. This is actually common knowledge, and brass is actually an alloy of copper and zinc, which is A. Now question 29. Here you were asked, the major raw material in the plastic industry is A, ethene, B, ethane, C, ethanol, and D, sulfur. So here also the correct answer is ethene, because it is actually the major raw material used in the plastic industry, in the formation of polymers and such. Then question 30 says, which of the following elements can form more than one acidic oxide? This one too, when you know your elements well, you know your metals and your non-metals, and you know the characteristics of each of them, and it will be easier for you to know the answer to these types of questions. You might be asked a question where you'll be asked to identify an element, whether it's a metal or a non-metal, using one of its characteristic properties. So here too, the formation of more than one acidic oxide is actually a property of sulfur. So your answer here is C. Next is question 31, which says the following properties are characteristics of transition elements except A. Formation of complex ions, B. Catalytic abilities, C. Fixed oxidation states, and D. Formation of colored compounds. So transition elements that are around the middle of the periodic table actually have a range of characteristics, and among them we have the formation of colored compounds. We also have catalytic abilities and the formation of complex ions. What we don't have is fixed oxidation states, because transition elements actually have variable oxidation states, which is why sometimes you need to calculate them, because in a particular compound the oxidation state of a transition element might be different from its oxidation state in another compound. So your answer here is C. Then the question 32 is an element X has isotopic masses of 6 and 7. If the relative abundance is 3 to 2 respectively, what is the relative atomic mass of X? So to find your relative atomic mass of X, you need to use these ratios that we are given along with the isotopic masses. This ratio is telling you that the relative abundance is 3:2. Or 60% to 40% if you convert it to percentage, while the isotopic masses is 6 and 7. So 6 corresponds to this ratio of 3, while 7 corresponds to this ratio of 2. So we can do a quick calculation to determine this. So we have X, and we're told that it has two isotopes. One has isotopic mass of 6 and the other has isotopic mass of 7. Then the ratio is 3:2. So for you to calculate your relative atomic mass, use these ratios with respect to these isotopic masses. So for this, it will now be, you can either use the ratio directly or you convert it to percentage. But since we're given the ratio, it will be easier for you to use the ratio. So you say your relative atomic mass is equal to 3 divided by the total ratio, that's 5. 3 plus 2 is 5, multiplied by 6, then plus your 2 divided by 5 times 7. This will give you 3.6 plus 2.8, and when you add them together you get 6.4. From your options, option C gives 6.4, and that's your answer. Now we move on to question 33, which says the activation energy of a reaction can be altered by A. Adding a reducing agent, B. Changing the temperature, C. Using a catalyst, and D. Applying a high pressure. So even though temperature and pressure actually affect the rate of reactions, but they don't really affect the activation energy. It's when you use a catalyst that it will alter the activation energy. So your answer is C. Then your question 34 says, which of the following is extensively used in manufacturing photographic chemicals? And your answer is actually silver chloride, because it is one of the major compounds that are used in the photographic industry in formulating the chemicals used. So your answer is B. Now question 35 says, which of the following separation techniques will show that black ink is a mixture of chemical compounds? So we have A. Sublimation, B. Chromatography, C. Filtration, and D. Crystallization. Now, among these techniques, it's chromatography that's actually used to separate colored compounds. So your answer is B. Chromatography. Then question 36 says a solution of sodium hydroxide containing 0.6 gram in 250 centimeter cube of solution has a concentration of. So to calculate this concentration, we are going to use the formula we used in calculating solubility in one of the previous questions. So we need to do simple calculation. Here also we need to calculate the number of moles of sodium hydroxide. So knowing the formula of sodium hydroxide, sodium is 23 gram per moles, oxygen is 16, and hydrogen is 1. You can add them up together to give 23 plus 16 plus 1 to give you 40 gram per mole. Then you are given the mass as 0.6 gram. So your number of moles is 0.6 divided by 40, which gives 0.015 moles. As for your volume, you were given 250 centimeter cube, which when you convert to dm cube will give you 0.25 dm cube. So your solubility or your concentration is going to be your 0.015 divided by 0.25, and this will give you 0.06 mole per dm cube. And that is your option C. Question 37 says detergents are much better than soap for laundry because A. Scum is precipitated when soaps are used with hard water but not with detergents. B. Detergents are synthetic while soaps are not. C. Detergents are more soluble in water than soaps. And D. Soaps are in bars while detergents are in powdered form. Now the answer to this question is you can notice that when you are washing and you are using hard water, there are some particles that rise up to the surface, and the cleaning effect is not too good when you use soaps, unlike when you use detergents. So your answer is A. Scum is precipitated when soaps are used with hard water but not with detergents. Then question 38 says when an element can exist in two or more forms in the same physical state, the element is said to exhibit A. hygroscopy, B. isomerism, C. allotropy, and D. isotopy. So when an element exists in two different forms or in a number of different forms with maybe differences in mass number, that is called isotopy. But when it's in the same physical state, such as carbon, where you have diamond, you have graphite, it's called allotropy, which is C. Then question 39 says greenhouse effect can be reduced by controlling A. water evaporation, B. the use of artificial fertilizers, C. the use of aerosols, and D. burning of wood and fossil fuel. Now actually greenhouse effect is mostly caused by the excess of carbon in the atmosphere and also other byproducts of burning of wood and fossil fuel. So when you control the burning of wood and fossil fuel, maybe using renewable energy and so on and so forth, you will be reducing the greenhouse effects. So your answer is D. And the last question, question 40, says waste plastics accumulate in the soil and pollute the environment because plastic materials are A. non-biodegradable, B. inflammable, C. insoluble in water, and D. easily affected by heat. So the major reason why plastics pollute the environment and do not break down is because they are non-biodegradable. That is, they cannot be broken down by organisms in the soil, unlike organic. Therefore, your answer is A. non-biodegradable. So with this, we've come to the end of this session, and good luck. Thank you.